Hi, everyone. Thanks for joining us today. We're just going to give a moment for everyone to log into the Zoom before we get started. Thank you all for joining. We're just going to wait a few moments, let everyone trickle in, and then we'll kick off our session for today. Okay, it looks like we have a good crowd. So hi, everyone. My name's Courtney Brown, and I'm a Senior Marketing Manager here at EDB. I'll be your host today for our webinar, Know Your Database Options in the Cloud. I'm joined by Mark Linster, Chief Technology Officer here at EDB. Before I turn it over, I'm going to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording after the broadcast to the email that you used to register for the webinar. All of your lines are currently muted. If you have a question, please feel free to submit it in the question panel. We expect the presentation to last most of our time today, but we'll allot any extra time we have to questions. If we don't have a chance to answer your question, we'll be sure to follow up after today's session. And with that, I'll hand it over to Mark.
All right, thanks, Courtney. All right, so we have a pretty full agenda today, but I hope we can ask some, we can address some questions. Don't be shy asking them because, as Courtney said, we'll try to get to them afterwards in writing and publish all the answers on our follow-up page. And the recording and the PowerPoint or the slides are going to be available afterwards. So let me go through this first. I'll give you a brief introduction about who EDB is, and I promise I'll stay within just a few minutes because I know you all want to hear about the cloud considerations and the things to know when you go to the cloud. Then we'll just talk a little bit about Postgres, why Postgres is the obvious choice for your database in the cloud. And I'm biased, so take what I say with a grain of salt. But I think Postgres is the way to go. Talk a little bit about the options that you have when you go to the cloud, and then the meat of the presentation will be about the things to know when you go into the cloud with your database. And I'll have at the end a set of resources for you, publications, benchmarks, best practices, etc. Things to keep in mind when you do this transition, right? Okay, so diving into it, talk about Postgres. We're the largest Postgres-focused company in the world. So today, with over 5,300 lifetime customers, over 300 technologists working on Postgres, very, very good customer satisfaction rating, and working with a large number of the Fortune 500 companies. So this is really important for you to understand, because you may wonder, why do these guys think that they can make all these recommendations? Well, it's because we've been doing this for now 16 years around the world with lots of companies, and we're very, very involved with Postgres, both on the commercial side and on the community side. So I think we're in a good position to have strong and well-informed opinions about how you take Postgres to the cloud. A wee bit of a timeline. That Postgres has now been, in development for 35 years. That was the initial moment when Mike Stonebreaker conceived of the concept after he'd worked on Ingress. PostgreSQL as an open source community has been around now for 25 years. EDB for 16 years. We've contributed a whole lot to Postgres. Here are just some of the things that we've done. And then in September of last year, we acquired Second Quadrant, who is also a very, very significant contributor to the Postgres community and the whole movement and the code base, with a lot of work that they've done around replication and high availability. So since then, we're really the largest company focused on driving Postgres forward, but by far not the only one and not the majority, but the largest for sure. Okay, so, what do we bring to the table today? We bring database and the supporting artifacts like monitoring tools, high availability, migration tools, etc., to the table that are needed to support all these use cases like database migration from Oracle, moving to the cloud, which we're going to talk about today, and then new application developments. And as I said, that includes the database, different flavors of the database or distributions of Postgres, as we would call them, and then all the tools you need to achieve high availability, management at scale, etc. And then, today we'll talk a whole lot about the way to deploy Postgres in the different environments, in the cloud, on virtual machines, in Kubernetes, and then, obviously all the services and support that you need. So, we're most proud of our Postgres expertise. Here, just a small snippet of the folks, the names that you may know. So Mike Stonebreaker, really the original designer of Postgres, is today an EDB advisor. Bruce Momgen, who's been driving the community forward, I think since its inception in '96. He's on the office, is in the office of the CTO, so he's on my team. Peter Eisentraut and Robert Haas are driving the development forward, and Simon Riggs, the former CEO of Second Quadrant, today has joined us as a Postgres fellow. So we're very, very active in the community, as I said, with 300 plus technologists, and then 26 named Postgres community contributors and committers. So we're very, very invested in making Postgres the best it can be and driving it forward every day of the year. Cool. So let's talk a little bit about Postgres itself. Now, I assume most people who are on this webinar already are into Postgres, but just in case somebody needs a little bit more convincing, we're obviously very proud of Postgres having won DBMS of the Year award by DB Engines now for the third time in a row. So that's a really, really good thing. What DB Engines does is it gauges popularity of databases, Mongo, MySQL, Oracle, SQL Server, pretty much everything on a periodic basis, and charts that. And you can see that the Postgres popularity has been growing tremendously in their rankings. If you need an argument in favor of Postgres, I would go check that out. And then the other argument is obviously Stack Overflow's annual developer survey, where Postgres has been a very, very strong contender, for many years now. In the most loved database, only Redis is ranking higher, but I'm not sure if I would call Redis a database or an in-memory cache. But certainly it's extremely popular. And I'll show you later on a different statistic that rates Postgres in containers. And you'll see that even in containers, Postgres is the most popular relational database today. So this is not just in, let's say, stodgy, old-fashioned migrations or something like that, but also in the cutting edge. So containerization, and with Kubernetes, Postgres today is the database of choice. So most definitely, we think Postgres is the obvious choice. Now, why did that happen? Well, because it covers a lot of use cases, a lot of migrations. I mean, we see a lot of people coming off Oracle, and they use EDB's specific Postgres distribution that has native Oracle compatibility built in. But then as soon as they look at that, they say, well, I can't just use it to get off Oracle. I can do new stuff with it. I can use it as my vehicle to go to the cloud. I can use it as my vehicle to develop mobile apps, apps with geoinformation system, etc. And then, it's really interesting here, the diversity of workloads. We see today in the most recent survey that we did of our customers, that over 60% of our customers use Postgres for systems of analysis. So not strategic big data warehouses, not a competition to Snowflake or something like that, but mostly tactical analytics and ODS, etc. So, and again, this is a testimony to the versatility of Postgres and the power of Postgres, right? So again, that's another reason it wins. And then, you can deploy it everywhere. It runs on every public cloud, whether on the infrastructure as a service or as a DBaaS. And it runs on every private cloud. It runs on virtual machines. It runs on Arduino. So, you can really make it work all over the place. And that's really why Postgres is winning this race. So now let's talk about the cloud journey. And before we dive into that, Courtney, if you could run our first poll, please.
Yes, of course. So here we go, launching our poll. Where are you in the database journey to the public cloud? So there's a few options. Feel free to take a moment, pick the one that makes the most sense for you, and then we'll share the results.
All right, so how are we doing here?
Pretty good. It looks like we about a little over half. Yeah, we're right near majority. So here, I'm gonna close the poll out. And here are our results.
Okay, great. So I think, for those that are in the public cloud already, hopefully we'll provide some good information. But for those who are just looking at it or in the process, I hope that we'll provide really good information for you. And by the way, Courtney, I think this polling data is going to be part of what we share with people afterwards, right?
Yes, we can do that.
Great. That would be fantastic. Because again, I guess everybody wants to know, where's everybody else? What are we looking at? And I think this is pretty much a good reflection of what we see in the market today. So let me dive into the cloud journey. Obviously, people are going to the cloud, right? Here's just some IDC data. And what's important for us is I also want to share with this audience here that, today, over 40% of our business comes from people who are running some, but not necessarily all of what they get from EDB in the cloud today. So we're fully invested with our customers in their movement to the cloud. And 82% of our customers are planning to move some of their workloads to the public cloud. So public cloud is definitely something that we see with our customers in pretty much every geography and also in every industry. So what does that mean? Well, all we're going to talk about today is, you're going to the cloud. Maybe you already picked a cloud. Maybe you're just thinking about cloud. And I'm going to talk to you about the options that you have and the things that I believe you should be aware of to make a well-informed choice. There's really three options of how you can run your database in the cloud. You can run it in DBaaS, so as a database as a service. Big names there are RDS, Aurora, Azure Database, Google Cloud SQL. You can do it as Kubernetes, right? So that's where you have the AWS EKS, you have AKS, and you have GKE, so Google's engine, and then obviously OpenShift, right? Those are like the big players. I know there's some other ones out there, but those are the big options. And then the third option, which is very, very popular still, is you run it on virtual machines. You use AWS as infrastructure as a service. You install virtual machines, or you use Google Platform Compute Engine as the same way. So those are the three options. The things to think about, and what we're going to spend most of our time with today is, what are the trade-offs of control versus agility? Lock-in or hybrid or multi-cloud? Which Postgres versions? And I'll walk you through where the differences are. What are the cost and performance implications? What are your support requirements? And again, I'm not saying that any of these options are better or worse, but they are more applicable and less applicable for certain applications and certain goals that you try to achieve. And I'll try to help you shed light on when to go towards which option and why. So things to think about. You've picked the cloud. Now, how do you choose these options, right? Like DBaaS, it's fast deployment. It's pre-configured. It's easy for the developer, right? Because within 20 minutes, you're going to be up and running. But you have limited tuning, configuration, and hardware and architecture options. Your cost is significantly higher, and I'll walk you through the cost per TPS for that option. And then what's very important and near and dear to my heart is The cloud service provider will provide you platform support, and that's different from Postgres support. And again, it's not necessarily a bad thing, but I want you to be aware of where the differences are and why and when that matters. Kubernetes is a little different. It gives you more flexibility, more configuration options. A Kubernetes operator, such as the one that you get from EDB, will encode some best practices. And that's important because with the operator, you can offload work that used to be manual and very time consuming and actually slowed down your agile motion significantly. You can offload that to the operator. The operator will do things like rolling upgrades, like switchovers, like backup, etc. So a lot of work that today often is manual, the operator will do for you. So you get more flexibility, you get encoding of best practices, okay? And this really makes sense if the application and the database are both orchestrated to Kubernetes. So if you're thinking about microservices, there's probably one that's an option that you should really consider. And again, it exists on every cloud, okay? The support's also different then, because now the cloud service provider gives you platform support. Postgres support you can get from a specialized Postgres company like EDB. Okay, and again, for an application that is mission critical and we really want to talk to a Postgres expert, I think that's something absolutely worth considering. And then the third option, virtual machines on infrastructure as a service. Every cloud offers that. Gives you much greater control over tuning, configuration, and architecture. It also requires you to know more about tuning, configuration, and architecture. So you have to be aware of the trade-offs because, you know, if you know what you're doing, this is like, I think, the best option to give you the most flexibility. But if you don't want to focus on configuration, tuning, etc., well, maybe Kubernetes is the better option, or even DBaaS, okay? And again, here you get infrastructure support from the CSP, and you can get Postgres support from a specialized Postgres company like EDB. So EDB has answers for all of your options. So it doesn't matter where you go, we can be there to support you. We, with specialized DBA services on DBaaS, and I'll show you why that's actually a good alternative, because you'll get a lot more bang for your buck if you have good support when you go to DBaaS. Kubernetes, we have what we call cloud native Postgres, which is a second generation Kubernetes operator for Postgres, very, very advanced, and I'll touch on that a little bit. And then, you know, if you go to infrastructure as a service or virtual machines, we offer extreme high availability. I mean, really carrier grade high availability there with tools like BDR, which came to us from the Second Quadrant acquisition. And then much superior monitoring, tuning, etc., and very low dollar per TPS. So and I'll walk you through those benchmarks in a second. Okay, and then, you know, if you come from a legacy environment such as Oracle or SQL Server and go to Postgres and you have the know-how, etc., this is a very attractive option. So those are really the three dimensions that we'll talk about in the rest of the conversation here. Okay, so we got two more polls here for you. Please, Courtney.
Yes. So our second poll launching right now. Here we go. What options are you choosing for your database in the cloud? So you're able to select multiple options here. So we'll just give it a moment for people to jump through. Okay, we'll give it about 5 more seconds. Okay, looks like we have a good majority, so I'm gonna close out the polling now. And here are the results.
Okay, that's interesting. Yeah, DBaaS, sure, it's very, very popular. Kubernetes on public cloud, also same thing. And yeah, I see that, yeah, we even have, I mean, I shouldn't say even, we have folks on the call who do SUSE Rancher, which I think is also a very attractive option since Rancher was acquired by SUSE. And then obviously OpenShift, now Red Hat or IBM, is also being used. So thank you very much. This is really good. Let's go to the other poll then.
Yes, our last poll. Here we go. What clouds are you choosing? Again, this is a question where you can select multiple options.
It's going to be interesting to see, right? The prior question was about like the platform on those clouds, DBaaS, Kubernetes, or virtual machines. And here we'll see a little bit more about the popularity of the clouds themselves.
Okay, we'll give it 5 more seconds. Okay, perfect. Here we go. Here are the results.
Okay. Now I know whose stock I'm going to go by. Yeah, that's not a surprise. I'm actually, well, a little surprised that Google is as close to Azure and that this is this kind of a distribution, right? So yeah, it'd be interesting to drill into what the other are. So thank you very much. Thanks for sharing that. Okay, let's dig in here. So key considerations. And I'll go a little fast here because I want to make sure that I'm going to be able to cover everything here. Key considerations, I believe, when you pick a cloud and a cloud deployment options is cost and performance. And you really need to understand this because the differences are very significant. I'll touch on some of them for the different clouds. The type of support, and again, that's near and dear to my heart because it's a database. This is where the company's crown jewels are, and you know, Postgres is extremely reliable, but sometimes you do need help, and you need high quality help, and you need it very, very quickly, right? I mean, if somebody tells you, yeah, we'll be with you in 15 minutes, that sounds reasonable, but when something goes bad, it's actually 900 seconds, which sounds like a long time, and it is a long time when things do go bad. And then how about high availability? Do you understand the high availability commitments that you're getting and how to manage it, right? Do you understand the security and audit capabilities? And then do you know how to migrate off your legacy, right? I mean, a lot of people don't just go to the cloud with new apps. That used to be the case in the beginning, but now we see a lot of migrations from existing data center-based applications to the cloud. So it's not just we go to Postgres or we go to the cloud. We go from, let's say, Oracle in the data center to Postgres in the cloud. That's a big leap. And are you being supported in the right way? Do you have the right tech? And then control and flexibility. That doesn't just appeal to the DBA, but that's also a compliance question. Those are things that you really need to understand. Do you have all the knobs available for you to control your destiny? So 4 things that we're going to dig into. Okay, so first, I'm going to talk here a little bit about AWS, and it sounds like that was the right pick. We have similar data also about Azure and Google. So if you're interested, let us know, and we can follow up with you. So what we did here is we did the benchmark where we took configurations. We have a small, medium, large, and extra large. For sake of the slide here, I didn't add the small, but we have standard servers, right? Standard server configurations, and that we then compare on AWS, we compare RDS, Aurora, and EDB performance, okay? So you can see here how the performance is rated. So AWS RDS is out of the box. AWS, so EDB Postgres with our Cloud DBA service on AWS, this is the performance that you're getting, and this is what you're getting with Aurora out of the box. Now, the benchmark that we're talking about here is being run with a tool called HammerDB. And by the way, the benchmark settings and the details and how to run this is all public, right? So please come to our GitHub. All the scripts, all the configuration information, everything is there. So if you think that, hey, this guy comes from EDB, he's biased, I don't believe this, that's perfectly okay. I'm not asking you to believe me. If you're interested, you can run the exact same tests using our scripts and our configurations, and either convince yourself that, you know, we're right, or tell us that we were wrong. Okay, so here is the perspective on transactions per minute, which is how HammerDB, which is a benchmark that's comparable to TPCC, is expressing its performance. This is TPM. Now we're looking at total annual cost. Okay, and you can see that that is a little different. Now, what's really interesting here is when you dig into the details there, I would advise you to not just look at the CPU cost. That sounds attractive, but actually the majority of your bill on AWS is going to be for storage and IOPS, okay? And databases are extremely IOPS hungry. So understanding where the cost is going to come from is very important. And again, we can share all those details with you. So if you now divide the dollars by transaction per minute, this is what you're getting, okay? Because now you can see that, yeah, Aurora is faster than RDS, but it's significantly more expensive than RDS. And if you calculate your cost per transaction, you actually find out that, you know, RDS is a better deal for this benchmark. And again, it's really important for this benchmark than RDS. So RDS is a better deal than Aurora. But what's even better is if you just take Postgres from EDB with the license and everything and Cloud DBA services and run it, because you'll get better tuning and you'll get much better utilization of all your dollars. And again, everything that we're sharing here, including the tuning settings, are publicly available. So if you have any doubt about this, please check it out. And, you know, if we're wrong, please let us know, okay? Good. What did we do in our benchmarking approach? We defined multiple t-shirt sizes, okay? And then we compared those across all public clouds, both for DBaaS and infrastructure as a service. The benchmark that we used is called HammerDB, which is an engine that was originally created by Intel, and is today licensed to the TPCC. Technically, it's called TP-ROC-C because it's derived from TPC. Yeah, we did all these comparisons. My colleague, Tom Rieger, a couple of weeks ago, did a webinar that was focused entirely on that, where he goes into this in great detail. The webinar, the slides, and everything is available on our website, okay? And as you'll get these slides, you can just click on the link and follow that. And he dives into that into a lot more detail. But again, the message here is cost and performance vary. And you have to dig into that, okay? Because, as I said, DBaaS is easy to use, great developer gratification, but it's more expensive than just running Postgres on infrastructure as a service, even if you add DBA services into the mix. Okay, second criteria that we're going to talk about is enterprise support. Enterprise support is not just important when things go wrong, right? I mean, obviously, that's what everybody thinks about, right? A bad thing happened, something broke, I need help. But what's really important is that you have a partner that you can work with. And I'll give you a couple of examples where customers have worked with us and said, hey, you know, strategically, I'm betting on Postgres, but I need the following things. I don't need them now, so it's not like an emergency, but I know that I'll need them next year. If I want to be successful on my journey to Postgres, I will need things like a different type of audit log. I will need things like tools to help me with PCI compliance. I will need things like improved bloat and vacuum management. Partner, can you work with me, right? So that I can be as successful in my Postgres journey as possible. So, and be aware of this. And for some databases, that's perfectly okay. The cloud service providers are focused on supporting the platform. They will make sure that the Postgres is up and running and that you can connect to it. If you call your cloud service provider and say, hey, this query was slow, is slow today, was fast yesterday, please help. Right? They will make sure that the platform is up, that you can connect to it, and that Postgres is running. All the other things that you truly value in a support partner, that's not there. And then the other part is they all run the same, they run the same version for everybody. So if there is a need for a hotfix, they can help you with a workaround, but they can't help you with a hotfix or a patch. Okay, that's very, very important. Again, doesn't matter for a run-of-the-mill, simple departmental, non-mission critical application, but when it really counts, it's important. Okay, here's just a little analysis of who contributed to Postgres last year, to Postgres 13. Here's all the company affiliations of the people who contributed to Postgres. And I mean, EDB, as I said before, is the largest Postgres company today. But what's really important when you pick your cloud provider for Postgres is look, are they in the circle? If they're not in the circle, they're not qualified to help you with patches or hotfixes. They're not. They can't, because they don't have anybody who actually works on Postgres and contributes to it. And that matters if things really go awry. Then you need this kind of help. So this chart tells you who can actually help you with Postgres and who can't. Input into the Postgres roadmap. You may say, well, why does that matter? Well, if you're an enterprise architect or a CIO or a VP of databases, you do know that it matters. Like, here are 3 examples of companies who came to us over the last couple of years and said, I need something. There was a company came to us and said, I need password profiles. Next year, they had password profiles because they wanted to push more PCI compliant applications to Postgres, right? Somebody else said, yeah, you know, the audit log does something funky, which is not a bug. It's just that's how Postgres works. If you do the alter user change the password, and if the logging level is at the highest level, the new password will actually be written to the log. They said, guys, we need change. We need that changed. So these are just examples of why it's important that you have a partner when you go to Postgres, right? Not just a platform where Postgres will run. That will limit you in how much you can actually do. And then a single source for all your Postgres needs, because we don't see a lot of people that run Postgres only in one cloud in one place. And we believe strongly that it's important to have one Postgres that runs for you everywhere, in your lab, in production, for highly compliant applications, on OpenShift with microservices, etc. We believe it needs to be the same version of Postgres. Okay, good. So I'm going to move a little faster here around the other enterprise capabilities, such as high availability. Obviously, you need to understand that and read the fine print when you go to the cloud. Okay, the fine print often says, yeah, we'll make sure that the cloud is available, but is Postgres up and running? What is your high availability? I mean, with tools like BDR, we can actually go to 5 nines. Can you do that with rolling upgrade? Okay, so that's really important, especially if you come off an Oracle mindset where you had Golden Gate and Rack, and you need to say, hey, I need to maintain my level of service. How am I going to do that? So those are the enterprise capabilities that you will need to do this. And here, just 2 examples of how we do that today. We obviously support streaming replication on the lower left, right, which also all cloud providers support, except that, you know, we also provide, when you set up your own Postgres on the cloud and use tools like EFM or Rep Manager, you can use synchronous replication. If you need synchronous replication, make sure that the cloud that you're going to will actually support that, okay? If you need even more than that, if you need higher availability than what you can do with streaming replication, look at tools like BDR. It is possible, right? So the important thing here is not that what RDS or Azure Database offers is bad, but the question is, how far can you push the envelope in your move to Postgres? And without tools like this, you're limited. You can go so far, and then you're done because you can't push high availability further. Enterprise capabilities also includes migration. A lot of people do migrations off of Oracle. And here really the facets or the aspects of migration. Schema and data is really easy, right? I mean, every cloud can do that. That's really straightforward, okay? And it comes down to code, meaning the PLSQL, the packages, etc. There aren't a lot of good choices there. Okay, I mean, yeah, there are some schema conversion tools. There's Aura 2PG and Aura FCE, but they're extremely limited what they can really do. And then you talk about the APIs, meaning Oracle compatible drivers, etc., and management tools, like something that is like Oracle Enterprise Manager or like Golden Gate, right? And because that's what you need to go all the way, okay? To really push the envelope again and not just take the bottom 20% of your applications and move them to Postgres, but potentially move everything to Postgres. That's when you need to start thinking about this kind of enterprise capabilities. The way we've done that and why I'm confident to say that, hey, you know, Aura FCE, Aura 2PG, etc. is kind of nice, but it doesn't hold a lot of water, is because what we've done is all the stuff in red here are things that we've added to Postgres in our Postgres distribution, or in one of our Postgres distributions called EDB Postgres Advanced Server. We've added things in this architecture like an Oracle compatible JDBC driver, even a driver that's compatible to OCI. So your application actually thinks that, hey, I'm talking to Oracle, okay? But in reality, it's talking to Postgres. It's just made believe that it talks to Oracle. But we've also, inside the database server, and this is a simplified architecture of the parser, the executor, the planner, etc. We've augmented pretty much every layer to make it look and feel to the application and to the DBA like it's Oracle, right? So we've added PLSQL understanding into the parser, obviously also into the executor and the planner. We've added things like hints. We've added database links, etc., all the way through, okay? So when you think about going to the cloud in this third group, right? So first we talked about cost and performance, then we talked about enterprise support, and now we're talking about enterprise capabilities. In there is important that you have the ability to get off Oracle, for example, because if you can't get off it, then again, you're only going to go so far in your utilization of Postgres, okay? So that's an element of enterprise capabilities that you really, really need to think about. And then control and flexibility, I think, is really important because let's say you want to go to RDS. It's very easy to get on there. And you can do a whole lot, but you only can do so much, right? So there's a limited number of knobs that you have to turn, to tune, to tweak. You're actually not root on your own database. Somebody else is. You just you're a power user, but you're not the super user on your own database. Some DBaaSs are quite far behind. I'll show you the details in a second. Okay. And then, you know, when you think about going to the cloud, really think about Kubernetes and cloud native Postgres as an option there, because I think it will really give you a lot of opportunities to do things your way that with a native DBaaS may not be possible. Now, maybe it takes you a little bit longer to get started, but at the end of the day, both from a cost, control and flexibility and support perspective, this may be the better trade-off. So, but dig into this a little bit. Control and flexibility, I talked about the versions. Here's a version table as it is accurate today, unless they change anything this morning. But Azure Database for Postgres, for example, is still in version 11. So there's quite a few things that were in 12 and 13 that you're not going to get. Google Database for Postgres is on 13, but RDS and Aurora are on 12. Okay, so there's a number of things that you're not getting, like deduplication of B trees and faster aggregates, parallel vacuum, etc. You don't have them. So again, this is something that you need to look at. And I'm not talking only about the specific things that today you don't have. What's important is when you choose to go with a DBaaS vendor, you're at the mercy of the DBaaS vendor. Okay, you're at the mercy of whatever they patch. So, for example, Azure Database today runs, I think, on 11.6 is the published version. I think 11.10 is the actual latest version for generation 11. They have backpatched major security flaws, but not everything. And again, when you're on a DBaaS, then you're not in control. Somebody else is in control. So you really need to understand that what you're doing there. And I'm not necessarily saying that this is a bad thing, but you need to be aware of it because I believe it limits what you can do. Okay. And as long as you're clear about that, everything's good. Give you more detail about tuning parameters. Okay, here are not all the tuning parameters in PostgreSQL.conf. It's actually a much, much longer list. But here are the key tuning parameters that we recommend in our tuning guides. And by the way, I'll give you the pointer to our tuning guides for Windows and Linux at the end of the presentation. So it's a very involved tuning guide that walks you through every one of these parameters and how to define how it should be set. The key message here is that not all of these tuning parameters are available on all the clouds. So if some of these are important for you, you need to know which cloud makes which parameter available to you, okay? And here gives you a little bit of a reference of why you should care, right? Okay, why is max connections an important thing to set? You can't set it on Azure. Last we checked, we think that's a problem. Okay, because you could easily swamp your database with a high level of connections and completely lock it down, for example. So again, this is not necessarily a rule out for Azure or Google Cloud SQL or AWS or RDS, but you need to be aware of these limitations. Okay. So control and flexibility. I talked before about containerization, and I think it's a really important topic that is coming rapidly. I mean, you know, we saw before in our survey how many people are deploying in containerized environments. So it's important, it's coming. But even in databases, in containers, Postgres is the #1 database. It leads in DevOps, okay? And it leads there because it can be deployed everywhere, okay? So when you make your choice to go to the cloud with Postgres, think about running Postgres in a containerized environment. It gives you great flexibility. And what's important also to remember is in that case, you will get the platform support from the CSP, who is very well qualified to provide you that platform support. And you'll get the Postgres support from a Postgres company like EDB, who is like our bread and butter is Postgres, okay? So when you make this choice, this is something that you should be aware of. Now, what does EDB provide in this case? Well, we do provide, you know, container images, obviously, but what's very important here is that we have developed what we call a second-generation Kubernetes operator. And that second-generation Kubernetes operator really uses Kubernetes to do high availability and the operations necessary to run the database in a containerized environment. So other vendors are using tools like Stolon or Patroni inside the container, right? to do this job. And that used to be necessary at the beginning of the move to containers for databases. It's not necessary anymore. Kubernetes has matured now to a level where this can be done right straight through Kubernetes. That makes configuration much easier, that makes the whole thing much more robust and much, much more elegant, and is a much better position to support the operator lifecycle model. And for those of you that are diving into Kubernetes, that's really something absolutely worth considering. Okay, so what does that give you? Advanced database features, automatically staying up to date, a whole tried and true operations model. And my colleague, Gabriele Bartolini, has written a very nice blog on our blog site about the 4C model, right? Where we're looking at cloud, container, and code as the way to certify security in this case. And then because the way an operator works, because it's a state-based operation, it does make sure that your deployment stays at the desired state, right? So what the operator does is you tell it in your resource description that I want 1 primary and 3 replicas. And what it will do is all the time try to reconcile the actual state with the desired state. You don't have to look. You don't have to get an alert and say, oh my God, let me go promote something. No, the operator does that for you all the time, okay? So that's the encoding of the best practices that is so important in the operator concept. And that is why it's really important to look at, what a second generation operator brings to you in simplifying the work that you have to do and making sure that as a DBA, you can look at the future projects, at the quality of the data, et cetera, and not look at routine tasks that need to be automated. So in conclusion here, I want to make sure that you all remember that, from our point of view, the selection criteria here, or the things that you need to be aware of when you make this move, is understand cost and performance, understand the support that you're getting, understand the enterprise capabilities, understand the level of control and flexibility that you want to have and that you will get, right? Same with the enterprise capabilities. All the cloud providers provide you high availability, but is it the degree of high availability that you want? Do you get enough of it, right? Am I getting the right auditing requirements, right? Do I have the right migration technology? Yes, they all say, oh yeah, we have something. But is it enough for what you want to do? If you have no need to migrate, well, then migration doesn't matter. If you have a large Oracle estate, migration capabilities become extremely important because, if you try to do it manually, you won't get there, right? If you want to move mission critical applications into the cloud, it's really important that you get the right enterprise level support. If all you want to do is development in the cloud, that doesn't matter, right? If you want to say strategically, we need to move so much to the cloud, for example, to get out of our Oracle ULA, and we need to get 80% of our estate to the cloud. Well, you need a partner to do that within the time frame that you have. If all you say, well, if I can do 10%, it's okay, or if I can do 50 databases, it's okay, good, then this doesn't really play as much of a role. So I'm not saying that any of the options are bad options. What I'm saying is you need to understand the trade-offs, and hopefully in what I've presented here, we helped you a little bit in understanding, what the trade-offs are, what the questions are that you should ask yourself. And these questions here, just to reiterate, is how mission critical are the databases that I want to move to the cloud to my success? Do I want a strategic partner, or, is it just a commodity and I don't really care about the roadmap? Do I want to avoid cloud lock-in? I mean, Kubernetes and containers are a great way to avoid that, for example. Do I need one throat to choke for all things Postgres, no matter where they are? Okay. If that's what you do, the cloud providers don't do that for you. They're good for one cloud, but not necessarily for what you do on OpenShift or on somebody else's cloud, okay? How important is strategic cost reduction for me as compared to let me get there quickly and I'll deal with the cost later, okay? If I already set up a cloud app infrastructure for my app, why can't I just set it up for the database too? A lot of people think, oh yeah, I just want to get somebody else to do this. But when you move your app to the cloud, well, the app has to live somewhere. It has to log in. It has to be installed. It has to be audited, etc. It has to be secured. Well, if you do that, you might as well do it for the database, okay? And then maybe use a DBaaS service to take care of your day-to-day operations. So here are some of the questions that I believe when you do this move to the cloud that you should be asking, and hopefully we've provided some answers here. And as I said, no matter where you go in the cloud, which cloud you go to, we're there to help, be it with Cloud DBaaS services, with our Kubernetes implementation, so cloud native Postgres, or with a virtual machine-based implementation where you can have extremely high availability and actually the lowest cost possible. So I'm going to go to questions and answers now, but here are some of the resources that I would highly recommend you take a look at. On the upper left-hand corner is my colleague Tom Rieger's webinar on the benchmarking and the sizing. He really went in depth. And again, he's sharing a lot of good data that's available on our website. There's an integration guide that we just published, Vibor and I, and then the tuning guides for Linux. Most of the clouds use Linux today, except for Azure Postgres, so that's a Windows implementation. So we also have a tuning guide for Windows at the same place, so you'll find that. And if you want to do your own deployments with virtual machines and integrate that through an infrastructure as code approach, we've published a large number of Ansible playbooks, plugins and roles on Ansible Galaxy. So just search for Postgres. You'll actually find the EDB Postgres is at the top as the most loved, the most downloaded. So here are some good resources that should help you first take the right decision, and then once you've taken the decision, help you be successful in your move to the cloud. So now we have a few more minutes for questions. Courtney, where do we go?
Great. Thank you, Mark. There were a few questions that came through about sharing the presentation. So I just wanted to remind everyone, we'll be sending the recording and the slides onto the email that you used to register. So no worries there. Otherwise, let's see what kind of questions came in. So does Oracle Compatibility work with database as a service, Kubernetes, and virtual machines?
It works with virtual machines and Kubernetes. Today, it does not work with database as a service. So Azure, Amazon, or Google don't have a native Oracle compatible version of Postgres. That is limited to the deployment on the clouds with virtual machines or Kubernetes.
Another question, do you have similar benchmarks for Azure and Google?
Yes, we do. Let us know. We'll obviously have your email, and if more people want to have access to those, please put it in there, and we can certainly share. Some of those we need to share in private conversation.
Let's see, it looks like we might have room for one more question. How do I decide if I should use a virtual machine-based approach or go with Kubernetes?
Well, if you're embarking on a journey towards microservices, right? So if you're saying, hey, I have very large databases and I want to chop them into smaller databases, I want to have greater agility, and so that's one thing. That's the move towards microservices. And then the second thing is, if your application is also being containerized, Kubernetes is the natural way to go, because what you can then do is you can orchestrate your deployments through Kubernetes, both for the database and for the application. That's really where the sweet spot is for Kubernetes. So if you go to microservices and your app is going to be containerized, then a Kubernetes-based approach is something that I think you should seriously consider. We also see customers who have a containerized application, but stay with virtual machines for databases. And that's often the case because they actually did not transform their databases into microservices. They put like a services layer on top of a relatively large database. So there's a bunch of different options. We'd be glad to talk to you about the details.
Okay, we had one more question come in. Someone wanted to know if you could elaborate on how performant containerized Postgres deployments are. They're just
there's not a good rule for that. The challenge, the reason why I'm saying that is that inside a pod, right? It depends on how you deploy, right? I mean, you could have inside a pod, you could have the application container and the database container. You get one performance characteristic in that case. If you only have the databases, you get a different performance characteristic. We've not done benchmarks on that yet, but there is really no reason to assume that performance will be worse with containerized environments. But again, I would suggest that you make that move towards containers when you also make the databases a little bit smaller. Because remember, the reason for containers was that we want to treat databases like cattle, not like pets. So if you have databases that need a lot of specialized tuning, and database A is completely different configured from database B and needs a lot of care and feeding, and only Joey knows how to take care of database B, and only Susie knows how to take care of database A, that's not a good recipe for containerization, right? Because in containerization, you want to have many, many occurrences of something that is very, very similar. So we can treat databases just like application containers, like cattle, and they're fungible and replaceable. If they are pets and they need a lot of TLC and they're unique, etc., they're not necessarily the right candidate to go to containers. So I know that was a long-winded way to give you no answer, but that's the reality.
Okay, thanks, Mark. We're right at the top of the hour now. So any question that we weren't able to get to, we'll be sure to follow up with. Thank you all for joining us live today. And Mark, thank you so much for presenting this session. We hope you all have a good rest of the day.
Thank you.